All right. Good morning, grade 12s. Sorry I couldn't be in today, but I wasn't feeling too good yesterday afternoon, so I'm home sick, unfortunately. So we are going to go over, I just want to go over this lesson for you. This is our last lesson in the unit. If you're having any issues, I think somebody mentioned last time that there was issues with the sound. If you're having any issues with the sound, you can click that little arrow down there, click the sound thing here, and if you click, see how it says speakers, Realtek audio. If you're on the computers in the classroom and the speakers are plugged in, you might have an option to change that setting there. Okay, or right clicking and going to opening sound settings would also give you an option. You can change your output right there. So if you're having any issues with the sound, you can do that there. Okay. Now period 2, you can skip through the first little bit here because we did these questions yesterday. Okay. They're the first example. So if you'd like, you can skip the example number 2. Period 1, we're going to go through the whole thing here. Okay. So yesterday, yesterday or Friday, for both classes, we focused on solving linear trigonometric equations. Today, we're going to solve quadratic. Okay. Remember, a quadratic is something like x squared plus 2x plus let's do plus 1, right? Typically, when we're solving quadratic equations, what we'll do is we'll factor this. So what times 1 equals 1? Add together to equal 2, right? X plus 1, x plus 1. And then what are my solutions here? Well, my solutions is x equals negative 1. So that's how we've solved, quadratics in the past. We've also, if we can't factor, we use the quadratic equation. That is a possibility here. The only difference is that in this unit, because we're doing quadratic trigonometric equations, is your equations might look something like this. Sine squared x plus 2 sine x plus 1. Right? Noticing here that really the only difference is the sign, okay? Which is going to create a few extra steps in our solutions, but we can still solve it using strategies from quadratics as well as strategies from trigonometry. So some applications, depending on what you're doing, the formula that contains a square of a trigonometric ratio. So sometimes we can have a square of a trigonometric ratio, like I've shown there. This leads to a quadratic trigonometric equation that can be solved algebraically or graphically. We will be focusing on solving algebraically. Quadratic trigonometric equations can often be solved by factoring. In cases where the equation cannot be factored, use the quadratic formula and then solve the resulting linear trig equations. So you could have to use the quadratic formula. Okay, so that could come up on a test or exam or your assignment. A quadratic trigonometric equation may have multiple solutions in the interval 0 to 2 pi. We will pretty much always be looking at this specific interval. Okay, some solutions may be inadmissible depending on the context of the question. So sometimes maybe like if you've solved quadratics in the past and it's asking a question about time, right? If you get a negative solution, well, time can't be negative, so we would say that's inadmissible. So depending on the context of the question. So the first question here, and I'm going to show you the strategy, and we're going to go through several examples here of how to solve these. Okay. Now, I'll tell you my strategy. Now, you don't have to do this, okay? But this is the strategy that I've used a lot in the past, and I found helps to simplify these questions, okay? So I'm going to write out our equation first. So our equation is tan squared x minus 4 tan x equals 0, okay? Now, the very first thing that I'm going to do after I rewrite that, you can even do it before, but I'm going to say let x equal tan x. You can choose any variable. Maybe I should use a different variable here. Maybe I use, let's say, because x is already in there, let's say a. Okay? So all I'm going to do is I'm going to take out the tan x's, and I'm going to put in the variable a. So this is going to look now like, instead of tan x squared, it's going to be a squared. Okay? Minus 4 instead of tan x, it's going to be a. So noticing here that the square stays on the a. That's very important. Equals 0. Okay. Now, this looks like something we've done in the past. Okay. My very first step here now, how do we solve a quadratic? We make sure one side's equal to 0, and then we factor. Since the right side is equal to 0, right, our right side is equal to 0, we can now factor this expression, or equation, sorry. I'm going to factor out a. We get a minus 4 equals 0. So what are my solutions? Well, my solutions are either a equals, so the solution for this one would be either a equals 0, or for this one, either a equals 4. Okay? Now remember, we are not solving for a. We earlier said what a is equal to, and we have that a is equal to tan x. So what we're going to do now is instead of a, we're going to write tan of x equals 0, or tan of x equals 4. Okay? Now we are going to solve these two equations here. Okay? Tan of x at 0. I'm going to solve this one by showing you on a graph, right? I told you yesterday on class period 1, last lesson, that it's important to have an understanding of what these graphs look like. So knowing that our tan function looks something like this, right? With a vertical asymptote here and a vertical asymptote here. Actually, I'm just going to change that last one. This is what a tan function looks like. And if you know what the tan function, if you know the properties of a tan function, right, this is really important. That's why I said you should know these properties. So knowing what these functions look like are very important. Where is tan of x 0? Well, tan of x is 0 right here at 2 pi. Tan of x is 0 right here at pi. And tan of x is 0 right here at 0. So my solutions for this one are that x is either equal to 0, pi, or 2 pi. So this one has 3 solutions. Now I'm going to go over and I'm going to solve my other one. The very first thing that I'm going to do here is I'm going to say, well, tan of x is positive here. So where is tan x positive? Using our cast, it's positive in the A and S quadrant. So I'm going to draw those. It's positive here, and it's positive here. Or sorry, the A and T quadrants. And now all I'm going to do is I'm going to type into my calculator. I'm going to determine what is, actually I'll zoom out just a little bit, what is x equal, I'm going to bring the tan over, and it's going to be the tan inverse of 4. Okay? All right. So I'm going to type that into my calculator, and you'll see that here. I'm going to type in, oh, look, there it is. Tan inverse of 4 is 1.32. Okay? Well, I know that tan is positive here. So this little angle right here is the angle that it's going to give me. So this here is 1.32. Okay? Now we're looking for two angles. That's our first angle. I now also want to know this angle. And how do I find that angle? Well, I'm going to say pi plus 1.32. And that's going to give me that big purple angle. Because I know that this little angle in here is the same as this. And I know that this is pi to here. So pi plus 1.32, which gives me 3.44. Okay, so those are my two other solutions. So 1.32 and 4.44. Rounding, so because there's going to be some approximations, your rounding is going to make a difference in these questions. Okay, I will accept a range of answers here. So either x is equal to 4.44 or 1.32. Okay, so all of my solutions are right here. X can be 0, pi, 2 pi, 4.44, or 1.32. Notice there are a lot of solutions. Okay, that's going to be the case for most of these questions. All right, I'm just gonna go through a few examples here to show you, so you kind of get the hang or the idea of this. Okay, we're gonna go through the next one here. So this one here, again, what I'm gonna do here is I'm just gonna say we're gonna let x equal sine. Oh no, sorry. I'm gonna use a again. Let a equal sine of x. So wherever I see a sine, I'm gonna substitute an a. So I'm gonna rewrite my equation. So I'm gonna write it as 2a squared. Notice that if the sine is squared, my a is also going to be squared. That's important. Plus a minus 1 equals 0. Well, again, this is pretty straightforward, right? We've done lots of factoring with these. Okay, remembering here that because of the 2 in front, this is a complex, so we have to use decomposition. So I'm going to factor this. What two numbers multiply to equal -2, right? And multiply that by the last term. Excuse me. And what two numbers add to equal 1, our middle term? Well, those two values would be positive. Why am I blanking? -1 and -1 and +2. Okay, so -1 and +2. I'm just going to pause this for just a moment here. All right, sorry about that. So yeah, -1 and +2. So I'm going to decompose my middle term. So 2a squared, -1 and +2, plus 2a minus 1a minus 1 equals 0. I'm going to factor. I'm going to common factor these two. Common factor these two. So we get 2a a plus 1. And we get minus 1 a plus 1 equals 0. I'm going to write this as 2a minus 1 a plus 1 equals 0. So my solutions are either, for the first one, a is equal to 1 over 2. For the second one, a is equal to -1. Now, remember we said what a is. A is the sine of x. So I'm going to bring these up, and I'm going to substitute sine of x back in. So for the first one, we get sine of x equals 1 over 2. And for the second one, we get sine of x equals -1. Okay? We're going to solve these. Excuse me. So sine of x is positive. Well, sine of x is positive in C, A, S, T. Sine of x is positive here and here. So I'm going to use my calculator. I'm going to take, I'm going to take the second sine of 1 divided by 2. We get pi over 6. So that tells me that this angle right in here, let's zoom in. This angle right in here is pi over 6. Okay, and now I need to determine this angle here. Okay, now if this angle in here, if this little angle in here is also pi over 6, right, because those two related acutes match, my orange angle, or this orange angle here, so I'm just going to put an arrow to it, this angle here is equal to pi from pi minus pi over 6. Oh. Now pi minus pi over 6, you can get a common denominator there, but I know that that's 5 pi over 6. So my two solutions are pi over 6 and 5 pi over 6. Okay? So remember here, I did x equals the sine inverse of 1 over 2. Okay? And that gave me x equals pi over 6. You can also use your special triangles here. We know that this is y over r, so this means my hypotenuse is 2. It means that this side here is 1, so this would have to be root 3. Okay, so you can also use special triangles. So my two solutions are x equals pi over 6 and 5 pi over 6. Now I'm going to look at sine of negative 1. So when is sine of x equal to negative 1? Well, for this one, for zeros and ones or negative ones, I always just like to sketch my graph. I don't even have to type anything into my calculator. My graph looks like this. I know that it's negative 1 right here. So I want to find the x coordinate of that. And if you know these graphs, you know that this is 3 pi over 2. So that's my only other solution. So my only other solution is x equals 3 pi over 2. So 1, 2, 3 solutions for this one. Okay. This one here, very similar to that previous one. Okay. For this one here, is this the one I have? I'm going to show you this one here. We'll keep going. So I am going to pick up the pace a little bit because this is very, it's very repetitive now. Okay. So with this one, we're going to let cos x equal a. So again, I'm going to substitute a in. So I write 6a squared minus a minus 5 equals 0. I need to factor this. So I'm going to multiply the 6 times negative 5. 6 times negative 5 is negative 30. So multiply to equal negative 30 and add to equal negative 1. Well, 6 and 5 work, and we need to be negative 1, so negative 6 plus 5. Okay? So we're going to write 6a squared minus 6a plus 5a minus 5 equals 0. I'm going to common factor out a 6a here. That leaves us with a minus 1. I'm going to factor out a, I'm going to factor out a 5 from here, so plus 5. That leaves us with a minus 1 equals 0. So we have 6a plus 5, excuse me, a minus 1 equals 0. So either a is equal to negative 5 over 6, or a is equal to positive 1. Now, we're going to sub cos back in for a. So that means that I'm going to go over here. Either, I'm going to do it this way. I'm going to do two different colors. Cos x is equal to negative 5 over 6. Or, cos x is equal to 1. Well, we actually already did this one earlier, right? When is cos of x equal to 1? Oh no, we did tan. Well, let's take a look. Notice here our interval. So 0 to pi. Okay. So when is cos x equal to 1? Well, if I do a quick sketch of my graph, this is my cos graph. Here's pi. So we can't go past. Our interval is before pi. So when is cos of x equal to 1? It's equal to 1 when x is 0. There's my first solution. Now, negative 5 pi over 6. Well, I'm going to draw my cast rule for that. C, A, S, T. When is cos negative? Cos is negative here and here. Now, I need to figure out one of these angles. So I'm going to take the x equal to the cos inverse of negative 5 over 6. Let's get the trusty old calculator out here. Second cos of bracket negative 5 divided by 6. Make sure you put the negative in there. It gives us 2.55. So that would be our first angle, which is this one. So that's 2.55. So either x is equal to 2.55, or we need to find the other angle. So that would be, the other angle is going to be this big one here. Okay. Couple ways to do this. The way that I'm going to do this is if the up there is 2.55, that also means that down here is 2.55. Okay, from here to here is 2.55. So what I can do is I know that a full circle, so if I were to continue this blue and I were to go blue, 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 all the way around, full circle is 2 pi, and I take away this section, this 2.55, oh, there we go, take away that section, so that's 2 pi, the blue is going to be 2 pi minus 2.55, and that gives me, excuse me, 2 pi minus 2.55 is 3.77. Okay, that's equal to 3.77. All right, so my other answer is 3.77. 3 solutions. The question is complete. Okay. Oh boy. Well, this is going to be fun. So now we get, I think I have 3 more examples to do. Again, I'm going to try to roll through these at a pretty decent pace here. Okay, you can watch this video back. All right, our assignment is still on Thursday. Tomorrow will be a review period. So I would recommend today, try and answer some questions here. If you have any questions about them in particular, please come and ask me. I will have extra help during lunch tomorrow. And it's a whole review period tomorrow. So please try the questions and ask me if you have or need help. Okay? So let's go with this one here. So this one is a little different because we don't have we don't actually have a quadratic here. Okay? So this is a bit problematic, right? So what we're going to do here is we like working with coses and sines. So I'm going to make everything here cos. So I'm going to make this 1 over cos 2x, right? Plus 1 over cos x, and that's equal to 0. Now, cos 2x here, this value here, right, they don't have the same denominator. But notice this here, right, that's a double angle formula. And we actually have a double angle formula for that. So I'm going to go just show you our double angle formulas. Our double angle formula for that, we have 3 options. And a few people have asked me, how do I know which one to choose? Well, you kind of have to look at the question, and you have to make a decision based on the question. Okay? So I'm going to look at my question here. Notice one denominator has cos 2x. That's what we're going to change. The other one has a cos x. So we probably want to just deal with coses. Okay? So I'm going to go back to my formula here. Of course, it didn't go right back to my formula. And we're going to just try to keep it coses. So that means that I'm not going to use this one, and I'm not going to use this one. So this is the one that has a cos. So 2 cos squared x minus 1. So we're going to go back, and we're going to rewrite this. And we're going to say this is 1 over 2 cos squared x minus 1. Minus 1 plus 1 over cos x. Okay? Now what we can do is unfortunately, we need a common denominator. But before I do that, and watch this, okay? Because again, this is kind of a step where it's a little easier. I'm going to say let a equal cos x. So watch what this does. Okay, I'm going to minimize that. Watch what this does. So I'm going to bring this and we're going to work this up here. So this becomes 1 over 2a squared minus 1 plus 1 over a. So we need a common denominator here. All right. So I'm going to multiply the top and bottom of this one by a. I'm going to multiply the top and bottom of this one by 2a squared minus 1 by 2a squared minus 1. Okay. Remember what happens when we get a common denominator for everything. It just becomes, we can cross it out. And that's what's going to happen here. So first we get, in our first fraction, it becomes a. This is in our second bracket. If I distribute this, distribute the 1, I get plus 2a squared minus 1 all over a bracket 2a squared minus 1 equals 0. If I cross multiply this denominator, it just goes away. And so all we're left with here is 2a squared plus a minus 1 equals 0. We factored something like this earlier. 2 plus 1 minus 1. I think we factored that right here. 2a squared plus a minus 1. We factored that earlier. So I'm going to use that. It was 2a minus 1 and a plus 1. So this becomes 2a minus 1 and a plus 1 equals 0. Now we're going to substitute. So we get here that either a equals 1 over 2 or a equals negative 1. Now, what is a? Well, I'm going to work back up here. So unfortunately, I got to do another. Ooh, and we're going to go here. So the first one, my first option here is either. So what is a? A is cos x. So I'm going to say cos x is either 1 over 2 or cos. Let's do a different color. Let's go back to my green. Cos x is negative 1. Well, this second one's very easy. We know that cos x is negative 1. If we sketch this graph, starts up here. Where is it negative 1? Well, it's negative 1 at pi. So my first solution is x equals pi. That's my first solution. It's only negative 1 once. And my other solution, well, I'm going to draw this. Right, I'm going to show you, if you don't have a calculator that gives you exact values, I'm going to do this just using special triangles. Okay, so we're going to zoom in and focus just on this. So cos is positive, so using cast, cos is positive here and here. Remember, cos is x over r, so I can put those values in. My x coordinate is 1, and my r is 2. Using your special triangles, the missing side is root 3. Continuing to use our special triangles, we know that this angle here is pi over 3. So my first angle, the angle from here to here, is pi over 3. So that's my first solution. So x equal pi over 3. Okay, sorry. And then we need to find this angle from here. So actually, I'll do this in a different color. Do this in blue. From here all the way around to here. And in order to find this blue one here, I'm just going to do 2 pi, because the full circle is 2 pi minus pi over 3, which is equal to 5 pi over 3. So my other solution is 5 pi over 3. Okay? So 1, 2, 3. All right. 2 more examples. Whew. All right. Modify and simplify. So one of our strategies here is to modify and simplify. Okay? Oh, look at this. I made a mistake. Notice the interval here. So 5 pi over 3 is not actually a solution because that's greater than pi. Okay? All right. Now, sorry, I just had to check something. This one here, again, notice things are not the same. Okay, things are not the same. This is an issue, but this is a double angle, right? Notice the 2 here, that's a double angle. We go back to our double angles. Notice on the other side we have a sine x. So let's go to our double angles. Boom. And this time we want to change. We basically want everything to be in. I'm going to change the cos 2, and I want everything to be in terms of sine. So notice we have this one right here that just deals with sine. So 1 minus 2 sine of x, or sine squared x. Go back. We're going to take this out. And we're going to, for here, we're going to sub in. Whoa. We're going to sub in 1 minus sine squared of x. Now, did I do that right? Please make sure on your test that you are copying these things down correctly. I missed a 2. That is going to have a major impact on a solution if you do not copy it down correctly. This is an open book assignment this week, so the expectation is that you are copying things down correctly. Okay? And I'm going to set this, right, our left side is sine of x. Now at this point, I'm going to say let a equal sine of x. So this is going to become a equals 1 minus 2a squared. I'm going to bring everything, because this is a quadratic, I need to set one side equal to 0. So we're going to bring these two things over. This becomes 2a squared plus a minus 1 equals 0. Notice that this is the same as this. So I'm not going to factor this again. Okay, if I write this out, I just write it out again. 2a minus 1, a plus 1. If you are having trouble factoring, I strongly suggest that you review factoring heading into this assignment. Okay, you are expected to be able to factor. Okay, that is an expectation for this assignment, for this course, that you know how to factor. If you do not know how to factor, you can come and see me at lunchtime. or practice. Okay. So we know here, and I think actually, what did we do last time? We did. Oh, that was close. So we have to do this again. So we're gonna do. Oh, okay. Well, I'm gonna pull it up here. So we're gonna go up here. We get either sine of x is equal to 1 over 2, or sine of x is equal to -1. Well, I always like to start the easier one. My graph of sine of x looks like this. So when is sine of x -1? Well, at 3 pi over 2. So one of my solutions is 3 pi over 2. My other solution is going to be, well, I'm going to draw this out. Sine is positive here. Oh, do some colors. Here and here. 1 over 2 is y over r, right, for sine. So that means this side is 1. This side is 1. This side is 2. This side is 2. Here it's negative. Oh, wait, I did that wrong. Whoops. Sine is positive here and here. So this is 1. This is 2. This is root 3. Root 3. And based on our special triangles, this angle is pi over 6. So pi over 6, pi over 6. So our first angle, our pink one there, x equals pi over 6. And our second angle, our blue one, is this angle here, which is going to be pi, right? I'm going to just do an arrow, pi minus pi over 6, which is 5 pi over 6. 5 pi over 6. Now, did I mess this up? Let's check our interval. Our interval is between 0 and pi. Well, these two answers are not applicable. That's bigger than pi, and those two were. So just one answer not applicable. Okay. I'm not going to do this one right now. I'm going to leave this one blank for the video. You can try this one. I will put the solution on OneNote. So this is a bit of a tricky one. Fantastic way to practice. This is your equation here. You probably want to switch everything to sines and cosines. Try this one out. I will post a solution. And if you want, I will go over how to complete that one on Wednesday morning, on Wednesday. Okay? If you have any questions, please don't hesitate to email me. I should be back tomorrow. Okay? Have a great day, everyone. And good luck with the questions. Oh, I'll scroll down just a little bit further. Here are your homework questions. Okay? There you go. Email me if you have any questions. Have a fantastic day. We'll talk to you all later.